Welcome for the brief demonstration of this is a single phase sine triangle PWM inverter. So you can see a very good quality polycarbonate front panel with a neatly labeled overall layout, as well as the various test points for firing circuits are provided, as well as a waveform for output voltage is provided. You can measure the input DC voltage, DC current also. You can measure the high voltage AC output also. Now to start with, I can show you how it can be tested. Basically the main start stop switch is on this side. Now this is the main DC link or ammeter. You can measure the input DC voltage here, and you can put an ammeter over here, digital ammeter or analog ammeter over here, and measure the input DC current. And if you wish not to measure that, you can just put a link across these 2 points. Then you can see these are the two variable potentiometer. This controls a duty cycle. Basically it controls amplitude of reference sine wave, and accordingly you get a variable AC output. Then in a limited range you can change the frequency of that fundamental frequency of the sine wave. Accordingly the output frequency will be changed in the range of around 35 Hz to 50 Hz. Basically inside this we have at TP5 fundamental frequency or reference sine wave, the 36 Hz to 50 Hz. Then the reference or the carrier frequency triangle waveform around 1.25 kilohertz. And then this is a triangle for the positive half cycle and triangle for the negative half cycle. So these two, it forms two channels, and these two channels are fed to the opto-isolator circuit, which is shown over here. They are fed to the opto-isolator circuit, and from opto-isolator they go to the four you can see MOSFETs over there. So this is how basically sine triangle PWM full bridge inverter works. Inside that you can see this is a low voltage AC we get, and then it is stepped up with the help of a step up transformer. And for getting a sine wave output, we are putting up condenser across the output or a filter across the output to get a sine wave. So basically you can measure all these parameters on the CRO. You can see on the CRO, you can measure on the multimeter as well as a ammeter also. So I will now, before I power on, I'm just getting this link out of that. Then there are two modes. You can see high voltage with LC, where this light will be blown, and low voltage without LC. So basically at a low voltage there will not be a output transformer connected as well as a filter connected. So at across this point I will be getting a low voltage output, which will not be a sine wave, which will be a more or a square wave. And if we want to measure or see the waveform of output of a high voltage output, this is the test point. It is called as attenuated for CRO for high voltage, and this is a low voltage for CRO. So according to these selections, either the waveform will come here or come over here. If you want to measure output voltage, a high voltage output, you can measure over here, and this is my lamp load. So I am putting a link now. As soon as I put a link now, I should be getting the light should be glowing if the selection is a high voltage. So right now the selection is a high voltage, the light is being glown, and you can see the waveform across a attenuated or at TP3. So at TP3 I am getting a sine wave output. The amplitude of the sine wave output will be changing according to I am changing the duty cycle. If I change the duty cycle part, the amplitude of the output will be changing. You can see the sine wave is coming, and the amplitude is either increasing or either it is decreasing. So according to the duty cycle control. And this is the frequency control. The frequency control is within the range of around 50 Hz to I would say 40 Hz or 36 Hz, and this is the maximum is 54 Hz to 40 Hz. So this is a range of frequency control, and this is the range of voltage control. So if you wish to measure the output voltage, it is around in the range of 140 volts or 130 volts to 220 volts, depending upon the load connected, not upon the line voltage, because we are having here a SMPS based DC power supply. 24 volts 3 ampere SMPS is used. So it is a regulated DC voltage source is given. So if now I wish to check just a square wave waveform without any LC filter, a low voltage square wave waveform It will be AC, but it will be a square wave. It will not be a sine waveform. So you can see this is, I would say, just a square wave inverter with sine triangle pulses generated, but because of lack of any LC filter or any transformer, we are not getting a AC here. Just a resistive load is connected across these 2 points. So these are the various test points. And now if you wish to check various test points, you can just go on checking the test point here. This is a reference sine wave at TP5. This is a triangle waveform at TP6. You can adjust the CRO.